All right, welcome back everybody to SAT Math Crash Course Day 2. We're in Part 2. We got Caden with us. We're solving some more problems, practicing that strategy of plugging in values in place of the variables, and using some basic logic here to eliminate answer choices. Let's work on question number 8 here. Go ahead and read that for me, please, Caden.
All right. The measure A in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. If the measure of an exterior angle of a regular polygon is greater than 50 degrees, what is the greatest number of sides it can have?
Okay, that is a confusing sounding question. And I'm guessing you have no idea what an exterior angle of a regular polygon is. Is that fair? Is that accurate? Maybe you know.
I have a slight idea.
Yeah. I agree. I would say the same as well. I have a slight, I mean, I've solved this problem a lot of times. I've got a vague sense of what an exterior angle, and it's an angle like on the outside. I think I could draw it, but I mean, you don't even need to know that here, right? All we know is we've got some number of sides for a polygon, right? N, right? And we've got some exterior angle, that's the A value, right, which is greater than 50. Okay, so A's got to be bigger than 50. Does that make sense? And some unknown number of sides. Yes. Question is, what's the greatest number of sides it can have? Does that question make sense?
Sort of.
Okay. Well, we're trying to find the greatest number of sides that gives us an A value greater than 50. And that number of sides is either going to be 5, 6, 7, or 8. I don't know what it is. We're going to test it. But if we plug in the answer choices for n, right, the possible number of sides, we find out what A is. If A is bigger than 50, we can keep it as an answer choice. But if it's less than 50, we've got to eliminate it.
All right. Yeah, I get it.
Does that make sense? Okay. So let's do it. Let's plug in a 5 for n, right? The temptation here, I think, is to plug in a 50 for A and solve for n, but it's not super clear if you approach it that way. Let's just test the answer choices. We can definitely eliminate the wrong ones and definitely confirm the right one if we do it that way. Okay. So let's do that. Let's plug in a 5. Let me write that out, just to save some time. Plug in a 5 for n, and we'll leave A, just sort of as a variable, equals 360. This might be the first time we're actually going to carry out an algebraic operation here. Okay, because we do have to solve for A now, but I think it's real straightforward. Do you know how to solve for A in this case?
I think so.
Okay. You can solve for A, right? You can find A if you divide both sides by 5.
Right.
Right? Because if we take 5A and divide it by 5, 5 divided by 5 is 1, so we just get A. And now I think this is a non-calculator section question. I'm not certain. I think it is. But just to save some time, go ahead and plug that into your calculator real quick. What's 360 divided by 5? Let's find out what that is.
Okay.
I think it's going to be bigger than 50. It should be. In fact, 72. I know it is. 72.
Yeah.
Degrees. Okay. Which is bigger than 50, so we can keep 5 as an answer choice, right? Because we get an A value that's bigger than 50 degrees. Does that make sense?
Yes.
Okay, but even just kind of logically, like I know 5 times 50 would be 250. I know that much, right? Even if you don't know exactly how to do like long division, you know what I'm saying? And this is again where like you can kind of leverage what you know. Focus on what you know, not what you don't know. I know that you may not know what 360 divided by 5 is. You may not be able to figure out that operation, but you know that's going to give you some value bigger than 50, because 5 times 50 is 250. So it's going to have to be 5 times some bigger number, some number bigger than 50. It's going to give you 360. Does that make sense?
Yes.
Okay, all right, so we know answer choice A is good. Let's keep it. Go ahead or let's, I'll write it out. 6 times A equals 360. We're going to test answer choice B now. Okay. So do you remember now how to solve for A here in just one step?
Yes.
What do we do?
You would divide on both sides.
Divide what?
6.
Divide 6 on both sides. Okay. So what is A when n is 6? You can plug that into your calculator if you want to. But yeah, I think you could kind of look at that and be like, no, that's going to be, 36 divided by 6 is 6. So 360 divided by 6 is probably 60, which it is. Okay. Right. Which is bigger than 50. Right? Mm-hmm. So answer choice B is a possibility, but we know 6 is bigger than 5. Right?
Yeah.
And the question is, what's the greatest number of sides it can have? So B is still a possibility, but we've eliminated A now.
Cool.
Does that make sense when we know it can't be A?
Yes.
I mean, A gives us, answer choice A gives us an angle, an A value, bigger than 50, yeah, but 6 is bigger than 5, so the greatest number of sides, it's possibly 6, but it's definitely not 5. Let's plug in 7 for N. Let's see what we get. So we've got 7A equals 360. What do we do to find A?
Divide each side by 7.
Divide by 7. Okay. Is that going to give us something bigger than 50?
I believe so.
I think so, right? Because 350 divided by 7 would be 50, right? Because 35 divided by 7 is 5.
Right.
So go ahead and plug in your calculator real quick, but I think we could estimate that. Just kind of figure it out. Let's confirm it.
I got 51.42 and etc.
Yeah, okay, great. But bigger than 50, right?
Yes.
So C works, but now we can eliminate B. Does it make sense why we can eliminate B? Or no?
Yes.
You can say no. If the answer is no, you can say no. I don't mind.
No, it does.
Okay, because
7 turns out to be still greater than 50.
yeah, and 7 is bigger than 6, so we can eliminate answer choice B. Okay, let's try answer choice D.
All right.
So it's 8A equals 360. Divide both sides by 8 now, which should be pretty obvious. Is that going to give us something bigger than 50?
No.
I don't think so, right? Because 400 divided by 8 would be 50. So if we take something smaller than 400 and divide by 8, it shouldn't give us 50. Let's confirm it. Plug into the calculator real quick.
All right. 45.
45. So we can eliminate answer choice D, confirm it's answer choice C.
Cool.
Any questions about that?
No.
Okay. I mean,
I got it.
yeah, I mean, you could plug in the 50 for A and then solve for N. You could do that, and you get like 7 points, something or other, you know. And so maybe just pick the thing, you might be able to figure out 7. That might work. I'm open to anything that gives you the right answer, but it's really odd. We can confirm it with absolute certainty that it's C, and we can eliminate the answer choices, the other ones, with absolute certainty by plugging in values for N. Does that make sense?
Yes.
And in general, I think it's just the best strategy. Instead of thinking in terms of like, boy, how do I solve this problem? Right? You're thinking in terms of operations. If you're thinking, how do I solve this problem? No. Say, how can I test this answer choice? How can I see if 5 gives me if 5 is a possibility? How can I see if 6 is a possibility? What about 7? 7 works. That's bigger than the others. Does that make sense?
Yes.
Testing answer choices is the best way to approach these questions. And then you don't have to worry so much about operations. I mean, you got to do a one-step, algebra, isolate a variable. But that's pretty straightforward. Any questions?
I don't think so.
Okay. All right. This one's a little bit trickier. Go ahead and read question number 10 for me, please.
Right. Which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1?
Okay. Boy, oh boy. What are we solving for here, Caden?
For which of the following equations has a graph in the xy plane? So which y is always greater than or equal to -1?
Yeah. I mean, I guess that's the question, right? I mean, but yeah, that's a little bit confusing, right? But if we were going to graph each of these answer choices, the correct answer choice has a y value that's always greater than or equal to -1. Does that idea make sense? What they're asking you?
Yes.
Okay. Now, if you're anything like me, I'm guessing you don't know exactly how to graph all these. I mean, I might be able to figure out. I'd probably actually test values if I were going to graph it. There's a way to graph absolute value. I don't remember exactly how to do that. I don't care. You don't need to do that. Okay? So I know that for the correct answer choice, there's no way to get a y value less than -1. There's no way, right? Because the y value is not, for the correct answer choice, the y value is never going to be less than -1. Does that make sense?
I think so.
I mean, like, if we were going to graph, right? I mean, like, if we're talking about actually graphing these.
Yeah.
Right? I mean, like, for the correct answer choice, at least, there's no way. If the y value is always greater than or equal to -1, I mean, the y value could be -1, but it's always got to be either -1 or bigger. It can't be less than for the correct answer choice.
Right.
Does that make sense?
Yeah, I got you.
Okay. So if there's some way to make the y value in these equations if there's some way to make it less than -1, if it's -2 or -3 or -4, -10 or -100 or whatever, I know we can eliminate it as an answer choice if there's some way to make the y value less than -1. Does that make sense?
Yes.
Okay, and again, that's sort of the approach. It's like, I don't know what the right answer is, but I can test the answer choice. I can find out, test some values to see if I can make the y value less than -1 for answer choice A.
Okay.
Let's do that. Okay, so if we can make y less than -1, so is there a value for x we can plug in? Let's just test values. Can we plug in a value for x that's going to give us a y value less than -1? Look at answer choice A.
So we could do 0.
Plug in a 0 for x, right? Make x equals 0,
Yeah.
and we'll get y equals the absolute value of 0 minus 2. Now, do you remember absolute value? Do you remember how that works?
Yes.
All right, it's in the rules for mathing. If you need to check it out, you can check it out. But, right, we calculate what's inside the bars, right? If it's positive, keep it positive. If it's negative, make it positive. What's the absolute value of 0?
0.
Just 0, right? So we get y equals 0 minus 2. What's 0 minus 2?
0 minus 2 is -2.
-2. So do we have a y value less than -1?
Yes.
We do, and we can eliminate answer choice A.
Cool.
Does that make sense?
Yes.
Because for answer choice A, the y value is not always greater than or equal to -1. We can make the y value -2, right? Because that's a spot, that's a place on the xy axis, right? That's the point 0, comma -2 on that graph. When the x value is 0, the y value is -2. Does that make sense?
Yes.
Okay, great. Let's test answer choice B.
All right.
Is there an x value we can plug in there that's going to make the y value less than -1?
Do 0 again.
Do 0 again. Y equals 0 squared minus 2. What's 0 squared? What's 0 squared?
0 squared. 0.
0. 0 times 0 is 0, right? Minus 2 is what?
-1.
Not -1.
Or not -1, -2.
-2, right? Yeah, -2. Right? So we can eliminate answer choice B because the y value is less than -1 for answer choice B. Does that make sense?
Yes.
Okay, great. Let's take a look at answer choice C. Is there an x value we can plug in that's going to give us a y value less than -1?
Well, yes.
What value?
I guess just like 1.
1? 0 doesn't matter.
Yeah.
Let's start with 0, just because that's what we've been plugging in. And let's work for the others.
Yeah, keep the pattern going.
Okay. Okay. And what does that give us?
That's 4.
Positive or negative?
Or negative.
No, it's positive.
Or no,
It's positive, right? Because that's -2 squared. Right here we can kind of talk about the properties of negatives a little bit. Right. That -2 times -2 is positive 4. If you get a negative times a negative, it always turns positive.
Right.
Does that make sense?
Yes.
You've learned that before, I suspect.
Yes.
It's positive 4. So we can't eliminate C yet. Let's try 1, right, which is what you suggested first. All right, so y equals 1 minus 2 squared, which gives us what?
That would be just 1, I believe.
Yeah, it's -1 squared, and -1 squared is positive 1.
Yep.
Okay, so we can't make that less than -1 yet. And I'm noticing a problem now. Right? Like if x is 2 or bigger, it's going to be positive, right?
Right.
But if we make x negative, even if that thing in parentheses here is negative, which it could be, right? If x is -10, make it really negative, right? We get negative. It's going to be -12 times -12. It's going to be positive. Does that make sense?
Yes.
I'm not sure we can make that less than 0. I don't think we can. We could make x 2 and we get 0, but I don't think we can make it even less than 0. Does that make sense?
Yes.
Okay. And this kind of takes us to the sort of the properties of exponents now. If anything's being squared, you know, once you calculate it, it's going to have to be positive or 0. You can't take something
Right.
squared and make it negative. Does that make sense?
Yes.
All right, so answer choice C is looking pretty good. Let's keep it. Let's take a look at answer choice D. Is there a value I can plug in for x that's going to give us a y value less than -1?
Yes, 0.
0 again, right? Which is what?
-2.
-2. We can limit answer choice D and confirm it as C. Any questions about that?
No.
Okay. Again, like thinking in like algebraic terms or like graphing terms, right? Woo, woo, not easy.
Yeah.
Certainly not obvious. But you can figure it out by plugging in values.
Right.
Okay.
Cool.
All right. Oh boy. Oh boy. Go ahead and read question number 12 for me. Just jump right into the question.
Okay. A website uses the formula above to calculate a seller's rating R based on the number of favorable reviews F and unfavorable reviews M. Which of the following expresses the number of favorable reviews in terms of the other variable?
Ah! Okay. What are we solving for here, Caden?
Which of the following expresses the number of favorable reviews in terms of the other variable?
Yeah, yeah. I don't know if we've seen this phrasing before on the SAT. I think we have. In fact, we remember the question with from the day one. Excuse me, the day one session with the air temperature and the speed of the sound wave.
Yes.
Remember, we said, and they said like which of the following expresses the air temperature in terms of the other variables, or something like that, or it might have been the speed of the sound wave. I don't remember, but it's the same phrasing, and it's the same concept here, right? It's kind of a fancy way of saying isolate F. I mean, look at the answer choices. All of them have F by itself on the left-hand side of the equation.
Oh yeah.
Do you see that? Same concept. Right, so it's really a fancy way of saying isolate F, which of the following expresses the number of favorable views, which is F, in terms of the other variables. It means get F alone, isolate F. Does that make sense?
Yes.
Okay. All right. So the algebra on this is not easy. It is tricky. Okay. Boy, and I used to teach this problem, going through the operations, and I've had a couple students that are able to figure it out. But boy, I mean, it's there's a lot of steps involved in that. It's not easy. It's not obvious at all. But there should be no surprise now. There's a way to solve this by plugging in values in place of the variables. Okay? So let's do it. I'll guide you through it. Okay. So let's come up with values for F, N, and R. Okay? But I don't want to start with R. Because if I start with R, then I'm going to have to come up with like very specific values for F and N that work and give us a true statement. Does that make sense?
Right.
And we've seen this before, right? Always when you're plugging values, always start by plugging stuff into the more complicated side of the equation, and then you're just doing arithmetic to find, what's isolated on the other side of the equation. Okay. So we're going to start by plugging values for F and N. This shouldn't be a surprise either here at this point. I'm going to make F equal 1. I'm going to make N equal 1. Okay. Right. What is R going to have to equal if N is 1 and F is 1?
It would have to be, because at the top it would be 1 divided by 2.
Mm-hmm. Yeah. Which is
So
1/2 or 0.5. If you're more comfortable with fractions, keep it as a fraction. If you're more comfortable with decimals, you can express it as a decimal. What are you more comfortable with, by the way, fractions or decimals?
Probably decimals.
Probably decimals. Let's do it. We'll make it 0.5. Is it obvious that 1/2 is 0.5?
Yes.
Okay. All right. Great. And remember also, by the way, if this is a calculator section question, boy, it's been a while since I've seen this on a practice test. I don't recall if it's a calculator or non-calculator section. But if it's on the calculator section, anytime they give you a fraction, you can always turn it to a decimal. Always. So if you're not super comfortable with fractions, turn it to a decimal in the calculator section.
All right.
All right. So let's see. Okay, so I know the correct answer choice. This is, kind of an equivalent expression question. The correct answer choice has to give me a true statement for these values of F, N, and R. So I'm going to plug those into the answer choices and see which one gives me a true statement. Any questions?
Cool. No.
Okay, let's do it. And I'll just plug this in for you here, just to the left of the problem. Okay, so I'm going to test answer choice A. And that is, F is 1, so we get 1 equals 1 times 1. What's 1 times 1?
1.
Yeah, 1 times 1 is 1, so we get 1 in the numerator. And then divided by 0.5 minus 1. Okay? Is that a true statement?
No,
No, it's not. Why? I agree.
because 1 doesn't, or 1 does not equal like negative 0.5.
Yeah, it's going to be 1 divided by negative 0.5, which I think is negative 2.
Right.
But again, you're going to have to know, it's going to be negative, right? Because you got a positive divided by a negative, it's going to be negative, right? Because that's going to be negative 0.5 here in the denominator. Is that clear?
Yes.
And you don't even have to, I mean, it's going to be negative. You got a smaller number, and I'm subtracting a bigger number from the smaller. It's going to be negative, right? So the right-hand side is going to be negative. That's not going to equal 1. So I can eliminate answer choice A. Any questions about that, or does that make sense?
Makes sense.
Okay, great. Let's test answer choice B. All right, so 1 equals R times N. Oh, you know what? I apologize. I just realized I plugged in 1 and 1 in the numerator. So I actually want to go back real quick. Do you mind?
Sure.
I want to go back to answer choice A. R times N. So I made a mistake. So it's 0.5 in the numerator. Well, it doesn't matter, does it? Right? Because the denominator is going to be negative 0.5.
Right.
Right? That's answer
Either
choice
way.
A. Yeah, regardless, it's going to be negative. You know, so that didn't actually make a big difference there. Okay, now we just realized I made a mistake. You don't need to be perfect here. Lord knows I'm not. You just need to know enough to find the right answer. All right, so let's go back to, let's go to B. So that's R times N. It's going to be 0.5 in the numerator. I'm just going to plug into the right-hand side of the equation. And then we get 1 minus R. R is 0.5. Does that equal 1?
Yes.
Yeah, it does, right? Because I get 0.5 in the numerator, and then 1 minus 0.5 is just 0.5. I get 0.5 divided by 0.5. Anything divided by itself is 1. That gives me a true statement. Let's keep it.
Cool.
Okay.
Right.
Answer choice C. Let's test that. So we've got 1 equals N is 1 in the numerator, divided by 1 minus R, which is 0.5. Is that a true statement?
No.
No. Right? We get 1 divided by something that's not 1. Right? 1 minus 0.5 is 0.5. I think it's going to be 2, so it's not answer choice C. We can eliminate that. Any questions?
No.
Okay. Let's do answer choice D. F is still 1. N is 1. And R, which is 0.5, minus 1. Is that a true statement? Cade?
It is not.
It is not. Right? What do we get in the denominator there?
You would get negative 0.5.
Yeah, negative 0.5, right? So again, that's going to be negative. I think it's negative 2, so we can eliminate answer choice D. B works. We can confirm it. It's answer choice B.
Cool.
That's right. Any questions?
I don't think so.
No? Okay. And at this point, you might be like, boys, you know, I think I see how the strategy works, but like this is so useful and it applies to so many questions and so many different kind of question types on the SAT. I mean, we're going to spend the rest of the session today working on the strategy, seen on different questions like this one right here, and even part of the day 3 session. It's just so darn useful. So let's read question number 14.
All right. A radioactive substance decays at an annual rate of 13%. If the initial amount of the substance is 325 grams, which of the following functions models the remaining amount of the substance in grams 2 years later?
Woo!
Okay.
What are we solving for here with this question, Caden?
Which function models the remaining amount of the substance in grams?
Yeah, the remaining amount of the substance in grams. Okay. Now we're starting with 325 grams. Okay? We're starting with 325 grams. And it's decaying at a rate of 13% every year. It's an annual rate of 13% decay. Okay.
Right.
Okay. Is that a lot or just a little bit? That decay rate of 13%.
That's, I don't really know.
Yeah, I mean, it's like, is 1% decay a lot or a little bit?
A little bit.
A little bit. 10% decay, a lot or a little bit?
A lot more than 1%.
More than 1%. But like, you know what 50% decay would be, right?
That's a lot.
That's what I mean. That's like half of it, right? If it's decaying at a rate of 50% every year, it's like halving every year, right? Does that make sense?
Yes.
So it's not a ton, right? It's not a ton.
Right.
It's close to 10%, right? So 13% is relatively close to 10%.
Right.
If you were going to give me an estimate of how much would be left after a year, I just want a ballpark. Like we're not even calculating this. How much would be left after a year of 325 grams if it's decaying at a rate of 13% a year? After 1 year, how much would you guess is left?
Jeez.
I just want a rough estimate here. I mean, we're not calculating it. We're just feeling this one out. It's just
like in like the high 200s.
I would agree, 100%, high 200s, right? And we can confirm that. I mean, look,
right.
if it's decaying at a rate of 10%, 10% of 325 is 32.5. So we're losing just a little bit more than 32.5 after 1 year. You know what I'm saying? Okay. So that's going to be less than 300, but not a whole lot less. High 200s, absolutely. 280, 290, something like that. Does that make sense?
Yes.
Okay. I think we can pretty comfortably estimate that. Okay. So all we got to do now is plug in a 1 for t. Let's make t equal 1.
Okay.
And the correct answer choice has to give us something in the high 200s. Does that make sense? Or should give us something in the high 200s. Right? It's got to be a little bit less than 325, not a ton less. Does that make sense?
Yes.
Okay. Now, I just found out recently that this is a non-calculator section question. Okay. So I want to see if we can look at the answer choices and kind of just estimate. Okay. We can plug in the calculator if we want to, and again, you might be able to do the arithmetic here if you needed to. But let's just estimate and think in logical terms here. Would we get something close to, or a little bit less than 300, if we plug in a 1 for t into answer choice A?
No.
Plug that in your calculator real quick. I want to see what we get.
All right. So. Wait, how would I do this?
So that's just so that's 325 times 0.87 to the power of 1. What's anything to the power of 1?
Just itself.
It's just itself, right? So that's just 325 times 0.87. Does that make sense?
Yeah.
Okay.
Oh, so it would be somewhat in the high 200s.
Yeah, that's a reasonable estimate, right? I mean, it's just 0.87 is just a little bit less than 1, right?
Right.
So I think that's a reasonable possibility, right? Go to punch it into the calculator. Tell me what you get. What do you get?
282.7.
There you go. 282.75. Beautiful. That sounds good, right? Okay. Now I'm not saying again, this is a non-calculator section question. You need to be able to sort of look at this, be able to estimate. But again, 325 times something just a little bit less than 1 is going to just be a little bit less than 325, not a ton less. Does that make sense? Why?
Yes.
You should be able to estimate that. Okay. Let's take a look. Let's keep answer choice A. That's possible. Take a look at answer choice B. Okay. When t is 1, what does that give us? And is that going to give us something close, just a little bit less than 300? We got 325 times 0.13. No. That's going to be a lot smaller.
Right. Yeah, for sure.
Right? Because, 0.13, that's significantly less than 1. I mean, if we're talking decimals or percents here. We are, by the way, going to spend, in fact, we're going to see this question again on day 4. We're going to approach it when we're going to spend half the session there on just percent increase and percent decrease, and we're going to approach this from a completely different angle. It's going to make sense. It's going to make a lot more sense from the perspective of percent increase and decrease. But right now, we're just estimating the values. That's going to be small. That's going to be like 10% of, or 1/10 of 325. That's going to be close to the 30 or 40 or something like that. Does that make sense?
Yeah.
Go ahead and plug it into the calculator. Yes. I'm curious what the exact value is here. But I think just estimating, we can realize, like, no, that's going to be too small. It's not going to be the high 200s.
42.25.
There you go. Right? Does that make sense?
Yes.
Okay. So just looking at that, you should be able to realize that that's just not going to give you something in the high 200s. Does that make sense?
Yeah.
All right.
Yes.
All right. Let's take a look at answer choice C. Excuse me. Is that going to give us something a little bit less than 300, maybe the high 200s?
Yeah.
Yeah, that could, right? In fact, that's the exact same calculation as answer choice A.
Yeah.
Right? It's just 325 times 0.87. Does that make sense?
Yes.
So let's keep that. I forgot we could eliminate B there. And then answer choice D. Is that going to give us something a little bit less than 300, maybe the high 200s?
No.
No way, right? Because that's the exact same calculation as the answer choice B. So that's gone. All right? We've eliminated half the answer choices. If this is as far as you get, I'm okay with that. Because at this point, Caden, you've got a 50-50 shot at getting the right answer. Which are pretty good odds.
Right.
Certainly better than 1 in 4 chance.
Yeah, for sure.
Okay. And if that's as far as you get, look, you're playing the game the right way. Okay, you're not going for perfection. Let me, I'm sorry to break the news to you. Let me help you out. You're not going to get a perfect score on the SAT math. All right, and for pretty much anybody watching the video, probably not. All right, if you're watching these videos. Again, like these videos here are designed to like simplify some really, really tough questions. You know, if you're shooting for a perfect score, you know, great, focus on the algebra, you know, focus on all the right operations, wonderful. But you know, we're not going for perfection here. We're just going for maximizing your score. And if you can take questions that previously you'd just be guessing on, you'd be like, I don't know, I have no clue how to solve that. And you can eliminate 2 of the answer choices. You've dramatically increased your score.
Yeah, for sure.
All right, just playing the odds, okay? But I think we can actually find the right answer here by plugging in values. Again, here's what we're going to do. We're going to plug in a 0 for t. Okay, and I want you to think about what this means here for a minute, Caden. Okay, when t is 0, that means no time has passed. Does that make sense?
Yes.
Okay, no time has passed at this point. Okay, so let's plug in a 0 for t, and what does the correct answer choice has to give us when no time has passed? What does it have to give us?
Just 0.
Well, if no time has passed, how much of the substance has decayed?
Then none.
Yeah.
Okay.
Nothing's decayed. So how many grams are left?
325.
325. All right. So let's plug in a 0 for t in answer choice A. We get 325 times 0.87 to the power of 0. And we went over this in the last session. What's anything raised to the power of 0?
Oh gosh,
It means it's being divided by itself, basically.
So then it would be 1.
1. Anything to the power of 0 is 1. So that's 325 times 1, which is what?
It's 325.
325. Does that make sense?
Yes.
Okay. All right. No time has passed. So let's keep answer choice A. That makes sense, right? If no time has passed, the correct answer should give us 325, which it does here. Okay?
Yeah.
Let's plug a 0 in for t into answer choice C. And I think you might be able to see the issue. We got 0.87 times 325 to the power of 0. What's 325 to the power of 0?
1.
1. So that's going to give us 0.87. Does that sound like a 13% decrease?
That's cool. Wow. Just
No way.
so that would not.
No way.
Yeah. That's. Huh.
We can confirm it's answer choice A.
Nice. So just by decreasing that value to making it nothing,
Yeah.
it really just puts a whole new.
Yeah. Yeah. And if you, in fact, if you start with 0, it might make more sense to start with 0. Right? Because then we can eliminate what answer choice can we eliminate right off the bat.
Take out the pretty much all of them except for that.
Not all of them. You can get rid of C and D right off the bat if we plug in a 0 for t, because those are going to give us 0.87 and 0.13. And we know the right answer choice has to give us 325. A and B would give you 325.
Oh yeah, because yeah, it's on the other
Does that make sense?
Yes.
Mm-hmm. But then, like, okay, what do you do? How do you, if you narrow it down to A and B, what do you do? Well, then plug in a 1 for T.
Yeah.
See which one gives you something a little bit less than 325. A would give you something a little bit less than 325, but there's no way B would. That's a massive drop. In fact, B would give you an 87% decrease for answer choice B. That'll make more sense again when we spend some time. We'll spend an hour on just percent increase and decrease, because that pops up a lot on the SAT. But again, you don't even need to know exactly how percent increase and decrease works. You can just plug in values and kind of estimate and figure it out. Does that make sense?
Right. Yes.
Okay. I'm telling. There's so many different question types where this approach of testing values works so beautifully.
Yeah.
Right. And any other sort of SAT program that approaches this exactly like a percent increase and decrease question, and it's all about the operation and all that, and kind of, and again, like, that's helpful. We're going to take a look at that perspective, but you don't even need to know that. If you can make it concrete, start thinking in concrete terms. If T is 0, it means no time has passed. The right answer has to give us 325 when T is 0, and it does here. Okay.
Okay.
All right. Question number 15. Go ahead and read this guy for me, please.
The expression is equivalent to which of the following?
Yeah, that expression. All right. Hey, it's an equivalent expression question. Be so happy when you see that word. Plug in values. Absolutely. I want you to do this. Show me exactly what to do. You know what to do here.
All right. Just put in a 1 for
Great.
5.
Great.
For the x.
Yeah.
Right. So then that's 5 minus 2.
Can you work that out on the whiteboard?
Yeah. That's fine.
Yeah.
Wait, what did I have for x?
X is 1, yeah. And by the way, when you're plugging values, I recommend really like setting that value and making it really, really clear so you don't forget.
Okay.
Okay. So when X is 1, what do we get?
Then that's 3 over 5.
Yep.
All right.
Yeah. Yep. You got it? All right, great.
All right.
So when X is 1, the expression of the question equals 3 over 5. Any questions about that?
Right.
Make sense?
No.
Okay, great.
Yes.
Let's take a look at the answer choices. We're going to plug in that 1 for X into the answer choices, okay, and see which answer choice gives us a 3 over 5. All right. Now notice answer choice A and B, there's no X, right? So let's just simplify that, right? So does 5 minus 2 over 3, does that give us 5? Or 3 over 5, I'm sorry.
No.
No, it doesn't, right? What does that give us?
It gives us 1.
1, right? You get 3 divided by 3, which is 1. Not 3 over 5, so that's gone. What about answer choice B? Does that give us 3 over 5?
No.
No, it doesn't. How do you know that?
Because it's subtracting the fractions just when.
Yeah, I mean, like, you don't even need to know, right? I'm guessing you didn't, like, find a common denominator in your head and do the calculation in your head, right? You just looked at it.
No.
Right? And if you're doing that, Caden, you're doing it the right way, man. You're doing it the right way. You are learning. It's exactly how you should approach this question. And when you're testing an answer choice. Exactly. Just look at me like, is that going to give me 3/5? No. I've got 5, and I'm subtracting something less than 1 from 5. Even if you don't know how to add or subtract fractions, right? You can look at that, but that's got to be bigger than 4, or whatever that is. Right?
Right.
Which it is. So just get rid of it. Don't even worry about the calculation. What about answer choice C?
So that'd be 2. Yeah.
Is that going to give me 3/5? That's the question.
It is not.
No, right? That's 5 minus 2 over 4, right? Which is the same issue as B, right? You got 5 minus something less than 1. Come on, that's not going to give you 3/5.
Yeah. Yeah.
Process of elimination, yeah, it's got to be D, which it is, even if you don't know how to add or subtract fractions.
Yeah, you don't have to.
No. I mean, and I'll show you why. I mean, that gives you 5 minus 17 over, what, 17 over 4. So you got to express 5 with a 4 in the denominator. I mean, the operation here is going to multiply by 4 over 4, right? Because what's 4 divided by 4? What's that? That's 1, right? So I'm multiplying 5 by 1. I'm not going to change the value of 5. I'm just going to change the form.
Right. So it'd be,
Okay, and that gives me 20 over 4.
yes.
Right. So 20 over 4. We do, haha, I just realized that this was not the issue here. Yeah, hold on. Little arithmetic issue. That's not 1 plus 4. That's 1 plus 3, which is 4.
Oh, I totally.
Yeah, not a big deal. But again, like, think about that for just a minute, right? I mean, how imprecise we were,
Right.
right? But still, like, I mean, but still, how easily we could eliminate the wrong answer choices here,
Yeah.
right? I made a mistake on an earlier question too. I mean, like, you know, you're going to make silly mental errors, but like, still, remember that one, that really funky one with the R, F, and N? But like, we got a negative number in the denominator, so we could eliminate the wrong answer choice still. So the others weren't even close.
Yeah.
Okay.
That's funny how
Did it-
off they were.
Yeah. Does that make sense though? I mean, like, that's not necessarily a problem. I'm going to keep this in the video. I'm not getting rid of this. You know, maybe some students had caught it earlier, like, "What are you doing, Mr. Dewey? That's not 3/5, it's 3/4." But that's fine. All right. I didn't catch it.
Right.
Okay. Okay. So we get that does give us 20 minus 17, which is 3 or 4. So
Cool.
answer choice D. Any questions about that?
No.
I mean, it's the only one that's even close.
Yeah. That's,
Okay.
That's awesome.
Yeah. All right. All right. Let's do. And by the way, you can plug in a 0 for x into this one. It works beautifully. Can I show you real quick? Plug in a 0 for x.
Sure.
Let me show you. Plug in a 0 for x. We get 0 minus 2. There's negative 2 over 3. So you get negative 2 over 3 when x is 0. Does that make sense? Why that's the case?
Oh yeah.
Okay. Does
I'm
A?
not doing 0 for.
Yeah, 0. Yeah,
That's
0.
like-
Ones and zeros, man. I'm telling you. Like almost every single one of these questions, we plugged in ones and zeros. Doesn't always work. And by the way, if it doesn't work, like if you get 2 answer choices that give you a true statement, great. Plug in a 2 or 3 if you need to. You know, keep it small. But answer choice A does not give us negative 2/3. That still gives us 3 over 3. Answer choice B is not even negative. C is not even negative. It's got to be D.
Yeah.
All right.
Cool. All right.
All right. Looks scary, man. Looks scary.
Yeah. It does.
But it ain't. It ain't. Let's do a few more.
Okay.
How you starting to feel about the SAT right now?
A lot better.
Good.
A lot better.
Okay. Go to read number 16.
The sales manager of a company awarded a total of $3,000 in bonuses to the most productive salespeople. The bonuses were awarded in amounts of $250 or $750. If at least one $250 bonus and at least one $750 bonus were awarded, what is one possible number of $250 bonuses awarded?
What are we solving for here, Caden?
One possible number of $250 bonuses awarded.
Yeah, one possible number of $250 bonus awarded. And we know we've got at least one $250 bonus and at least one $750 bonus. And they've got to add up to what?
At 3,000.
They've got to add up to 3,000. Okay. Let's test values, man. Let's test values. Let's do that T-chart again. We got some number $250 bonuses. We got some number $750 bonuses. Right?
Okay.
Let's test some values, see what works. As long as it adds up to 3,000, we're good.
All right.
Right? There's got to be at least one $250 bonus and at least one $750. So give me some values.
So we can tell that it's not going to be 1, because that just wouldn't add up to that.
Well,
It's got to.
well, it could. Well, I mean, it could. I'm not saying it's 1, but if let's say we've got one $250 bonus, is there a number of $750 bonus that would give us 3,000? That's the question.
Okay.
You see what I'm saying? Yeah, I mean, it's not going to be 1 and 1. That's not going to work.
Right.
But what if we do like 1 and 3 or 1 and 4, something like that? You know what I'm saying? Like 3 of these guys?
Yeah.
Go ahead, let's use a calculator here.
Okay.
What would that give us? That would give us 750 times.
2,250.
2000, that would be 2,250.
Yes.
Okay. What about 4 of the $750 bonuses?
Okay. That would be 3,000.
I'm gonna double check here. I'm not sure that's. We got 750 times 4. No, I guess 750 times 4 is 3,000.
Right.
Right? Plus the $250 bonus would be 3,250.
Oh yeah, I always looking at that.
Right? Does that make sense?
Yeah.
So you were just looking at the $750 bonus. Does that make sense?
Right.
So if it was 3, so that's too much.
Yeah. You would have
If
to
it was
add
3, yeah, right? Does that make sense? So if it was 3, we would get. Well, let me just. I'll leave that 4 there. Let me test
that
the
would
3.
come out to 2,500. I think.
I'll do 1 and 3. I think it's going to be too. Well, I know this is going to be too small. Yeah, it's going to be 2,500 because I'm just taking away $750. Does that make sense?
Yes.
All right. So.
And if that's 2,500, then you would need to add 2 more of the 200.
Ah. So you want to test 3 for the $250
yeah.
bonuses? Let's do that. So 3 $250 bonuses, and then how many of the 750s?
3.
3 of those. What does that give us?
That should be 3,000.
It's 3,000. It is. 3 is our answer.
Nice.
Any questions about that?
No.
Okay. Again, the approach there is testing values. Like,
Yeah.
there might be a specific operation to find the right answer. Like, you could, like, set up an equation or 2 equations, maybe a system of equations. Like, I don't know. Maybe. I don't care
Yeah.
that there might be an algebraic operation. There might be. I'm sure there is. I don't know what it is, and I don't want to do it. Because I know if I can keep my arithmetic straight, I'm going to find the right answer.
Right.
It's not going to be a big number. We're not talking about, like, 423 $750 bonuses. It's going to be a small number. Right?
Yeah.
Relatively small. And I think if you test values, I think 3, 6, and 9 would work of the $250 bonuses. But just test the values. If you can do the arithmetic and keep that straight, which is, there's a little, not always, as proven by this video, especially when I'm working at 12. I am working a 12-hour day today, interestingly. So doing the arithmetic is not always perfect. But as long as you can keep that straight, you're gonna find the right answer.
Yeah.
Okay. Any questions?
Cool. No.
Okay.
All right.
Question number 18. This one's interesting. Let's do a couple more. Go and read this
In
one.
the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationships between A and B must be true?
Yeah, that's a good. That is the appropriate response to this question. I remember seeing this question for the first time and just being like, "What the heck is going on here? Like, I have chosen the wrong job. Like, there's no way I'm making as an SAT tutor. I had no clue. No clue." Okay. Boy. Okay. A couple things about this. First, take a look at this, where they say if 0, 0 is a solution to the system of equations or inequalities, right? Whenever they give you a point on a line, right, or an ordered pair like that, they're begging you to plug in those values for x and y.
Okay.
They want you to plug in the 0 for x and the 0 for y. In fact, I've got it on a section of my Rules for Mathing in the Basic Concept cheat sheet. I think it's Basic Concept K. Plug in points. I'm going to read this real quick. It's I don't think you have access to the Rules for Mathing in front of you right now, but I'm going to read it. It says, whenever they say this point 0, 0 or a, b is on this line or is a solution to this system of equations, plug in those values for x and y. Okay? Which should make sense, right? Because like, why are they telling you 0, 0 is a solution to that? Why would they be telling you that? Well, 0 is an x value.
Yeah.
0 is a y value. We know that if we plug in a 0 for x and a 0 for y, we're going to get a true statement for both equations, or both inequalities. Does that make sense?
Yes.
Okay. Okay. So let's do it. Let me see you do that. Plug in a 0 for x and a 0 for y. And let's just see what happens.
Okay.
Can I see you do that on the whiteboard?
Yes. All right. So it would be 0.
Now we can plug in. We can plug in a 0 for x as well, right? Looking good.
All right.
Okay, looks good. All right, so we've got 0 is less than negative 0 minus a. I think negative 0 is just 0, right? And then 0 is greater than 0 plus b. We can simplify that. Okay, we can simplify those two statements. I'm going to rewrite. Well, first let's simplify the top one. We get 0 is less than a, and then for the bottom one we get 0 is greater than b. Does that make sense?
Yes.
Okay. Now, the funny thing about this one, like, if you say 0 is less than a, I'm like, okay, 0 is less than a. It doesn't tell me a whole lot about a, or it's not immediately obvious, at least, right?
Yeah.
Like, I don't know how to digest that. You know what I'm saying? So I'm going to flip that around, and I'm going to rewrite it as a is greater than 0.
All right.
That makes a lot more sense to me, as far as, like, the significance of a. Oh, a is greater than 0, okay. Or it's positive, great, easy. Some positive number, bigger than 0. Wonderful. Does that make sense?
Yes.
Okay. And then this guy down here, I'm going to rewrite that as b is less than 0. Oh, okay. I know what that means now. Just easier to digest. Does that make sense? I mean, you might be able to look at these two and figure that out. That's fine. But when I express it the other way, like, it just intuitively makes a lot more sense to me.
Yeah, for sure.
Okay. I'm not a math guy. Like, I need to express things in terms I understand. So, which is okay. Most people are not math people. All right, but I think that makes sense now. Any questions or no?
No.
Okay, all right. All right, so now let's look at the answer choice. It says, which of the following relationships between A and B must be true? Take a look at the answer choice A.
All right. So A is greater than B, which seems to be true.
Does that have to be true? If A is greater than 0
Yeah.
and B is less. Yeah, that sounds about right. Okay, look at answer choice B.
That's not true. That's the opposite.
No, B can't be bigger than A, right?
Yeah.
If B is negative, no way. What about answer choice C?
Um,
Does it have to be
that's
true?
No.
No, because like if A is negative, or if A is 1 and B is negative 1, you get 1 equals 1, right? They'd be equal.
Yeah.
A wouldn't be greater than, so it doesn't have to be that way, right?
Okay, and then A is probably not going to be
No.
equal to.
Doesn't have to be true,
Yeah.
right? I mean, it could be if A is 1 and B is negative 1. And this is what, interestingly, we plug in values again, really. We could create values for A and B if you wanted to test them, right? Make A 1 and B 1,
Yeah.
right? Make A 1 and make B negative 2, whatever. You know what I'm saying?
Mm-hmm.
And then plug in those values into the answer choices. If you needed to make it concrete, if you're just looking at these expressions, didn't do it for you. You know what I'm saying?
Right.
Like, make A 1, make B negative 2, and plug them in. Does that give you a true statement?
No.
No, you get 1 equals 2. Okay. Now, by the way, and it's a little bit trickier because if you did plug in values and plugged in a 1 for A and a 1 for negative, or a negative 1 for B, you would get a true statement there. You'd be able to eliminate. You'd be able to eliminate B and C, but you wouldn't be able to eliminate D. You know what I'm saying?
Yeah.
If you plugged in a 1 for A, or 1 for A and a negative 1 for B. So, oh no, I got two true statements. What do you do? Just plug in another set of values. Yeah, look at it like an experiment. Just test values. Make it arithmetic.
Yeah. All right.
That's not bad, is it?
No, it's really not.
No. I mean, you got to kind of know like the SAT secret code, right? And the secret code here is they want you to plug in plug in the 0 for x and the 0 for y.
Right.
You know, that's what
So
they're.
once you find that out,
Once you realize that, yeah, then it's just it's pretty basic
just lay
arithmetic.
it out.
Yeah, but just looking at it and like thinking in algebraic terms, like,
Yeah.
come on,
Oh,
no, absolutely.
Yeah.
All right, but it doesn't have to be that way, Caden. It doesn't have to be that way.
It's good news.
Okay, it is great news. Okay, we're gonna do one more. This is the last one.
All right.
And boy, I love this question. All right, go ahead and read it for me, please.
All right. A food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day?
Okay, Caden, this is a system of equations question. Is that obvious or no? Maybe it's not obvious.
Yes.
I mean, you've seen systems of equations word problems before.
Yeah.
I'm guessing, Algebra 1, Algebra 2, certainly. And this is a classic systems of equations question. You've got two variables, right? Two unknowns, the number of salads
Right.
and some number of drinks, and they're giving you enough information to create two equations, two unknowns, systems of equations. Okay, there's a way to do it to set that up. In my experience, most students really struggle with solving systems of equations. I mean, really struggle with it.
Never good at those.
Yeah,
I remember seeing these and being like, well, I hope this is the right
and
answer.
yeah, exactly. Like, and I used, you carry out the operation of like, you get some numbers, like maybe that'll work, But and I used to coach that. I mean, I used to teach all the algebra. I used to go, here's the operations, here's the steps, But like student after student would just like butcher these. And so, anyway, but there's a way to plug in values to solve this. Okay. There's a way to test the answer choices. And again, this is instead of thinking about what's the operation, think about, okay, could it be answer choice A? Could it be answer choice B? Could it be answer choice C? Could it be answer choice D? There's a way to do it. Okay?
All right.
All right, so let's do it. We've got two variables again here, so we're going to create that T-chart.
Okay.
Okay? So we've got some unknown number of salads and some unknown number of drinks. All right? So S and D.
Right.
Does that make sense?
Yes.
All right, so the question is, how many salads were sold that day? Let's test answer choice A, 77 salads. All right?
Okay.
If 77 salads were sold, how many drinks were sold?
And that would be.
And remember, that says 209 salads and drinks were sold. It's a real easy calculation.
132.
132, right? Because it's just 209 minus 77, right?
Right.
Okay. Any questions about that?
No.
No? Okay, great. It's going to be really easy now to find out how much revenue was brought in from 77 salads and 132 drinks. How do we calculate that?
Okay, so for drinks, since that's only $2, then that was just 2 times.
Yeah, which is what? You can use this is a calculator section question, so you can use the calculator.
264.
$264, okay. And how many salads?
And then the salad.
Or how much in the salads?
For
Mhm.
6.
Yeah, it's just 77 times 650 or 650, $6.50. What's that give us?
So 500.5.
500.5, so that's $500.50. Okay. Does that give us, it has to give us $836.50. Does it give us that?
Does not.
It does not, right? It's like 700 something, 764.
Yeah.
It's not $836.50. So I can eliminate answer choice A. How do I test answer choice B?
Change the values.
Yeah. 93 salads, how many
Right.
drinks?
So then. Oh, my bad. 116.
How much revenue from the drinks?
That would be 232.
How much for the salads?
604.5.
$604.50. Does that add up to $836.50?
Yes.
Sure does. Answer choice B.
Don't even have to test out the ones.
Nope.
Nice.
Nope. Every single systems of equation question in the SAT you can solve this way.
That's crazy.
Every single one. And if you wanted to, you could go through C and D. There's no need to.
Yeah,
The B works.
unless you've completely checked every answer and you're like,
Yeah, and we go, I'll go back and check just to make sure. But you can feel pretty confident about that, right? No operation to mess up. You're just doing arithmetic. Okay. Now, if they give you a question like this and there's no answer choices, you got to come up with your own values and test your own values, right? If there's one of the, because there's writing questions sometimes, and I've seen that too. But still work. I mean, you come up with your own values. If your value is too big, then try a smaller value.
Yeah.
And if that's too small, try a bigger value. Just play with it.
Just adjust.
Yeah, absolutely. Especially if it's a calculator section question, you just punch those numbers in the calculator. Yeah, you'll get it. It may take a minute or two, but you're going to get it. And here, it doesn't take long testing it this way. Does that make sense?
Yes.
Okay. How much algebra have we done so far these past few days?
I think we ended up doing one.
I think we did one step. Yeah, one step. So we did like half an algebra.
Yeah, if even.
But that's it. And these are all like algebraic, questions, involving variables and unknowns and all that. You can turn them all into arithmetic.
Yeah.
Again, there's just a handful of questions, maybe 3 or 4. I'll say 3 to 5 just to be safe on every SAT that really requires specific algebraic operation, like completing the square or, quadratic formula or something like that. There's some.
Right.
But don't worry about those, man. Just focus on the ones you can get for sure, like this one, if you can approach it the right way and turn everything into arithmetic, which you can.
Yeah.
Okay.
That's awesome.
Any questions?
I don't think so.
Okay. Let's wrap it up right there. Good. Okay. So, between now and when I see you next, I'm going to send you links to the videos. Again, you can check those out if you have questions about solving any of the questions. I do want you to solve them, again, on your own. I think it's super, super important.
All right.
To just practice the strategy and just you got to make it automatic of plug-in values. But and you got to just change it. Just change that mindset. Don't ask yourself, okay, what's the operation? What am I supposed to do here? Oh no, it's like, okay, could it be A? Could it be B? Could it be C? Let me plug some values in for the variables here and see what works, see what makes sense on word problems. Look at it like an experiment.
Yeah.
Okay, and then it's just a series of puzzles. Like I used to get so nervous before I taught the math section of the SAT when I first started tutoring. It was like I'm like, oh boy, I'm gonna see if I can do the operation on this question. And I just don't like. I know you throw any SAT problem at me now. I mean, like I know the right way to look at it.
Right.
I don't have to memorize any operations.
That's awesome.
Okay.
All right.
Okay. Well, good. Well, I'll send you all that along with the homework, so make sure you practice that. And then in the next session, we were going to practice. We'll do some of the homework questions and cover those, but we're going to focus on a new strategy of approaching geometry questions by using visual estimation and another strategy I call the bootleg ruler. I'll show you all that. But it's all about simplifying. You don't have to do any fancy operations on many of the geometry problems. I'll show you what that looks like in the day 3 session. Okay.
Sounds good.
Okay, Caden, appreciate your hard work, and I look forward to seeing you in the day 3 session. All right.
All right. Thank you.
Take care. Bye.
Take care.